So in order to calculate the values that go in this chart, we just need to follow the equations that are right up here. So for surface area, we are going to take length times width times 6. So they give us the dimensions, okay? So length times width, so 0.5 times 0.5 times 6. And we end up getting 1.5. For volume, we're going to do length times width times height. So 0.5 times 0.5 times 0.5. We get 0.125. And then remember, we're trying to figure out what the best deal is. We know that cells want to have a really big surface area compared to their volume, because the surface area represents their cell membrane. And if they have a really big cell membrane, that means they can move stuff in and out really quickly. So we take the surface area number, divide it by the volume number, and we end up getting 12. Now this is really 12 to 1 because it's written as a ratio, but if you just put 12, that's okay. All right. So down here, length times width times 6. So we're going to have 1 times 1 times 6. So we'll end up getting 6 here. Length times width times height, 1 times 1 times 1, which is 1. So I'm just going to write 1 there. And then surface area to volume ratio, we got to take the surface area divided by the volume. So 6 divided by 1, which is going to equal 6. Okay. Now, we don't know just quite yet which one's going to be the fastest, or maybe because you already watched this link, you know. So take a look here and see if you can figure out, we're going to be asking down on the bottom, is a big surface area to volume ratio good or a small one? And remember, we need our tube or our cube to be able to move things out in and out quickly.